Thank you. I know it's really cold, and I know you guys probably want to get some beers soon. And I like that you're sitting over there by the air condition. That's a nice move. Maybe instead of beers, we should get like hot tea or something. So, anyway, my name is Thomas Watson. I'm just Watson on GitHub. And I'm WA7SON on Twitter, which is lead for Watson as well. So I work for this company called Opbeat. And what Opbeat does is it gives you like a nice overview of what's going on in your, I'll try to see if I can talk louder here with all this noise. It gives you a nice overview of what's going on in your production systems on your server. So when you have a web server, you can see like the performance and if there's any errors and nice stuff like that. And I work with JavaScript every day. I work with Node.js in particular. And I'm responsible for making sure that if you have a Node.js app in production at Opbeat, then you can monitor that. So I'm writing the Node.js agent that you run on your server if you do that. Anyways, when I'm not at the office and coding, I'm coding somewhere else. I travel a lot. These are some of the places I've been in the last 5 years, living or traveling and working as a digital nomad. And if you notice, Portugal is actually on the map. It's because I lived in Portugal last year for about 5 months. So I was really excited to be invited here back to Lisbon. That's really awesome. Thank you. But when I'm not, or while I'm traveling, I always keep in touch with all my nice, cool friends on GitHub because GitHub is awesome. And I do a lot of open source on GitHub. I publish a shitload of stuff. Most of it is probably not that useful. Most of it is in the mad science category. I try to do stuff with weird protocols and stuff that you probably would take for granted, and I try to build it from scratch just because I can and just because why not? And so that's what I'm going to talk about today. And I'm going to talk about how you can build your own printer in JavaScript with no hardware. And you're probably thinking, why would you want to do that? Because printers are awful, like paper jam, shit like that. Like it's, by the way, a little secret. What's going on actually is, this is what's going on. And you get like weird error messages that you have no idea what does that even mean, right? So I decided to dig into that. And before I tell you the details about that, I want to tell you how I got to that idea, or how I came to that idea in the first place. And it all started with, a couple of years ago, I was trying to figure out a way for me to do AirPlay in JavaScript. So AirPlay is basically all your Apple products. They have something called AirPlay, and you can have your phone stream a YouTube video to your TV, or you can play music from Spotify on your system, on your loudspeakers at home if you have an AirPort Express. And that's all AirPlay that's powering that. It makes it really easy to just like open your phone and select your TV or select your speakers and say play music or play this video. And it just works. There's no configuration. So while I was trying to do that in JavaScript, I realized that it's using this Bonjour protocol that you guys maybe know. And actually, that's just Apple's branding of the standard called zeroconf. And zeroconf is actually just a kind of like a fancy layer on top of multicast DNS. So I was like digging through the whole stack, getting down to the old school stuff, and reading a lot of RFCs. And I was implementing this, and part of the standard is called DNS Service Discovery, or DNS SD for short. And that basically allows you to have a service on your network. You just plug in a printer, for example, like this one, or like your Apple TV, and your Apple TV just appears on your phone, and it just works. And you haven't really configured anything. You haven't given it an IP address, or you haven't really said anything about it. It just appears automatically. So I was looking in the list of all these different services you can advertise on your network, and this one in particular drew my attention. It's like IPP Internet Printing Protocol, and that was normally like printers in my head is something that's really like horrible, and you need to install drivers. And I knew that when I was on my Mac, I could just say install a printer, and it usually just worked. But I wasn't really sure why. I thought maybe Apple just bundled a lot of drivers with OS 10 or something, and maybe that was why it worked. But then I was like, Internet Printing Protocol, that sounds interesting. Let me dig into that. And I realized it's basically just a standard that uses HTTP to send for your client, for example, the operating system, to communicate with your printer. And as you can see, it's just setting the content type of the headers here. In the headers, it's setting it to application IPP. And that's basically all that is to it. And then down below, you will have the body of whatever is being printed, but not like a regular HTML body. Of course, this is like some binary format. So I looked into the binary format and realized that it's actually just have a list of operations that it can send to the printer. So you have stuff like get the list of jobs that's on the printer, or cancel that job, or hold the job, or restart the job, and stuff like that. And the way it works is that IPP will always use the HTTP post method, and then it will just post to the printer. Every printer have a path on the network. But to tell the printer what you want it to do, you specify this operation ID in the third and fourth byte of the body. So just to quickly show you what that looks like. Yeah, we can actually see the top there. That's good. So the top there, that's just like saying, OK, we're talking IPP version 1.1. So the printer and the client knows that they're talking the same version of the protocol. And here's the operation ID. This is operation ID 11, which was get printer attributes. Then you have a request ID. And the request ID is just basically because HTTP runs on top of TCP, of course. So the client just opens a TCP connection to the printer. And it can send like a lot of requests. And to know, it might not get the request back in the right order, in the same order that it sent them. So to know what the printer is responding to, you have to just echo back that request ID. And then you have a list of headers. These are not HTTP headers. These are headers inside the body. They're called attribute groups. And attribute groups is a way for the client to tell the printer what it wants to know, or extra metadata about the print job. And you can have multiple of those. And it's basically just a fancy key value system. You guys have good tent builders here, I hope. Anyways, so you have a name and a value. So all the headers are like that, and you can have different types. Here's the Boolean. And at some point, you get the end of attributes tag, 03. And then after that, you get the actual document, if you're printing a document. Because as you saw from before, a lot of the stuff hadn't anything to do with printing at all. It was just getting jobs, or getting like how much toner is left on the printer, stuff like that. So I implemented a very, very low-level implementation because that other stuff is really annoying and hard to read, so I don't want to read that. So I implemented this instead, which is called Ivp Encoder, which is basically just, this is JavaScript, and this is actually Node, so there is the require, oh, you can't even see that. So above this, I'm requiring the Ivp Encoder module. And I'm just decoding the buffer I get from, so let's pretend we are a server. Now we are a server, AKA a printer. So let's pretend we are a printer. So I get some data in a buffer, and I decide to decode it. And I get the decoded object, which is a nicer way to interact with all these attributes we saw before. I handle the request in some way, and then I send back a response to the client. And the response is very similar to the request. It also has a status code, and you echo back the request ID. And then it has the same headers or attribute groups. And you can set different stuff, like the default char set, or you can even have strings in different languages. So the client can show error messages and status messages to the user depending on the language of its operating system. And then when you're done with that, you just encode it, and you get a binary blob back that you just echo back. So I thought it would be fun to actually make a printer. And I found out that the minimum set of stuff you need to do to be like a proper printer is you just need to implement the ability to print a job, of course, because otherwise it's not very funny. You need to be able to validate the job, get the printer attributes, so that's like how much toner do you have left, or is it like what kind of paper is in the bottom tray and all that stuff. Get a list of jobs that's currently on the printer hooks. Cancel the job or get job attributes. So get job attributes could be like the name of the print job, or who sent the print job, or how many pages are there in the print job, stuff like that. And I released that on GitHub. It's called Ivp Printer, and I want to show it to you. So I couldn't even spell. It was so cold when I was typing this, so I couldn't spell SINFO. So basically, it's real simple. We do npm install. So npm, for those of you who don't know, I'm going to sit down here. Oops. For those of you who don't know, npm is the Node package manager. It's basically just a fancy way to get software onto your computer. So I installed the Ivp printer. Can you guys see this, by the way? It's the size. Whoa, yeah. I guess you can see that. Let's clear this. It's actually really simple. We just make a file, and we require the printer. It's always fun when you do live demos like this, because you know how the demo gods, they tend to not work the way you do. So let's give it a name, and this time I'm actually trying to spell SINFO correctly. And it's what's called an event emitter. So we can just listen for a job on the printer. So every time there is a job on the printer, so basically every time somebody sends something to be printed, we want to do something with it. And we could, for example, say new print job. Print that out, and have a name, so we can print that. And in this case, let's write it to the file system. If I can spell require. And there's a handy module for that in Node called fs. And let's give it a proper file name. So let's say print job, job ID. Let's expect that it's in the PS format. The PS format is PostScript. And let's make a file, and like this. How many of you guys have programmed in Node.js before? Quite a few. Nice. And let's just pipe the job. The job is a stream, so we can just pipe the job, if I can spell pipe, into the file. And let's, when the job ends, so ends means basically that we're done printing. Let's just write written file name, like this. OK, so that's the printer. This is 13 lines of code hidden behind a shitload of modules that I wrote. And now we run it. Nothing happens right now, of course, because we haven't sent anything to the printer. We haven't even installed it. So if I go in So there's my mouse. If I go into printers and scanners, and I click the little plus icon, lo and behold, I have a SINFO printer. This is interesting. Let's print to that. Let me say add. It's like, yep, boom, done, perfect. Let's find something to print. Oh. Yeah, let's print this. I can't see the top of the screen here. This is going to be interesting. There we go. This is better. So let's print this. And selected it here. And let's click print. Let's go back and see what happens here while it's printing. So now the operating system is trying to print, and boom, there we have a print job. And you can see he even got the name of the page I was browsing, or I was printing, actually. So let's try to look at this. Look what this print job 1. Boom. There we have a PDF. It's actually a PS, but whoops. I don't know what I selected there. But it converted it to a PDF for me. Anyways, it works. Don't save. No. Quit. Delete copy. Whatever. Yes. Thank you. OK. So that's it. Is that my talk? No. There's more. So what can you do with this? You could, for example, make your own printer that every time you print something, you can print it to your Kindle if you own a Kindle. So it just appears as a book or a document on your Kindle. Or you could print stuff to your accountant so he can do your taxes for you. Like every time you have a receipt, you buy something off Amazon, you just print it, and it boops, goes to print the receipt, and it goes to your accountant. Or you could print something, and it will make it into a photo and attach it to a tweet and tweet it automatically every time you print something. Or you can make something called NCF-ACP, which is a fancy acronym for NSA, CIA, FBI Auto-Centering Printer. So basically, before it prints something out, it just blocks random stuff. Because you can also actually print stuff out. You don't need to save it to disk or email it. You could just be a proxy between the actual printer and the client who's trying to print it, which opens up the idea for some really fancy stuff. Anyways, I put this online as well. So you guys know HTML bin and stuff like that? I made something called print bin, which is this. It's basically like a public printer. It's on the internet. And everybody can print to it. You guys can print to it as well. You can actually do it right now. And you just follow the guide here. Let's just, I think maybe I already installed this. So you just write print bin. And what it's doing is it's advertising the print bin server on the network. But instead of pointing to a local printer, it points to an internet IP that's actually on Heroku. So your operating system just thinks, oh, it's a local printer, but in reality, it's a printer that's hosted on Heroku. So now I'm going to add the print bin printer. And you only need to do this once you've added it, it works. You don't need to run this, but this is just an easy way to add it, basically. And so let's try to print this page. This is really meta. Let's select the print bin printer. So now it's printing, and it's sending the print job to Heroku. And Heroku is doing stuff with it, and it's putting it on S3. And if you reload the page, hopefully while I was talking, there it is. And we can click it, and we see it. So we have to be, luckily nobody have printed nasty stuff to it, but you never know. And everybody can see every print job that everybody prints. Just saying. Okay. But that's all fun and games. What about security, you ask? Thank you for asking that question. So while I was doing all this, this is something I do for fun because I like reading RFCs and it's really weird. I have a problem with my brain, maybe, I don't know. So while I was reading all this stuff, I couldn't help thinking, like I was reading through the RFCs and I realized the way this works, so the way that your Apple TV works and the way that the printer works, that you just plug in and it just works, is that it's normally when you have a DNS system, you have somebody asking for a query, saying, or making a query asking for something. So it will say, what is the IP address of SINFO.org? And some DNS server will respond back saying, oh, this is the IP address of SINFO.org. Okay, cool. But in multicast DNS, instead of just talking directly to the DNS server and the DNS server just responding back, everybody on the local network can see the communication. So you just broadcast to everybody because there is no DNS server. The whole point is that you don't need any configuration. So you just broadcast, what is the IP address of SINFO.org? And then there might be a DNS server somewhere that says, oh, I know that. And it responds back, this is the IP address. And it responds not only to that person, but to everybody else. So everybody on the network now knows what the IP address is for SINFO.org. So there's actually nothing that inhibits you to be able to just say, let's pretend somebody asked me what the IP address for SINFO.org is. Let me just like broadcast it out to everybody, even though nobody asked me. And then now everybody knows the IP address for SINFO.org, even though nobody asked. And that is how your Apple TV works. When you plug it in, it boots up, and nobody is asking, is there an Apple TV? But the Apple TV just says, let's pretend somebody asked, and just says, hey, I'm an Apple TV, and I'm running this version of the software, and you can talk to me, and I have these features. You can do like screen mirroring, and you can like, whatever, play music on me, stuff like that. And then the cool thing is that if you have a printer and it boots up and the printer says, oh, I'm a printer, and you install it, then if the printer shuts down and you take the power out and power it up again later, it might get a new IP address. But you don't want all your users on your network like having to like reinstall the printer just because it got a new IP address, because it has the same name. So what you want to do instead, you want to have all the clients just use the name as the key, and if they see another printer or somebody else with a different IP address having the same name, they just assume it's the same printer. And this can be a problem, I found, because, oh yeah, one last thing. So what happens if two printers on the network are called the same? If the name is the key to connecting to it, what if two printers are called the same? So there is a rule so they thought about that when they made the RFC, and there's a rule that says, if you are a printer and you have the name SINFO, and somebody else on the network say, hey, I have the name SINFO, you have to change your name. So now the original printer that was called SINFO is called something else. So yeah, so the attack vector I'm going to explain is using zeroconf. And the way it works is that you as an attacker, you send a malicious MDNS packet on announcement on the network saying, oh, I'm called SINFO, I'm a printer, and I have this IP, and I have this port. And then the actual printer is forced to change its name. And then at the same time, all the clients on the network just see, oh, now the SINFO printer have a new name. Have the same name, have a new IP and port. And if you're really clever as an attacker, what you do is now you get all the print jobs, but you don't want everybody to know that, so you just forward them to the actual printer. And so nobody knows that you're actually intercepting all their print jobs. So this is basically a man-in-the-middle attack. And this was all theory, and I was reading the RFCs, and I was thinking, this should be possible. Wonder if it is. So I tried to do it at work, and suddenly I could read everything that people were printing. And I thought, why not publish this so everybody else can do the same thing? And it's on GitHub. It's called BCC for Blind Carbon Copy. And this is going to be interesting. Now see if the demo guys are with me here, because I'm going to try to hijack this printer here. We tried to set it up before, and it was really messy, and I'm running it off my mobile phone as a network. So I need to just join my phone here on my computer. So now that's done. And then I need to see if I can find the printer now. There it is. Oops. Don't do that. I was messing about with this before. Why can't? Well, fuck it. Let's. I just tried this once before, and let's see if it works this time. Last time I didn't have to download anything. Let's try to do it in let's try to, what did I do last time? Did I do like this? No. AirPrint, that's better. Fingers crossed. Okay, good. So now we have a printer. And just to show that this works, let's print this page here. And hopefully this will start to spit out stuff soon. So what is you can't hear that, but it's printed now. So okay, so it works. Good. Boom. So you can still see this. Good. So I made this tool, and you install it, npm install BCC, and then you run it. And it looks on your network to find all the printers on your network, and it gives you the possibility to select one of them. In this case, there's only one. I'll select that. And now it's just waiting. It's already taking over the printer. And my computer here just thought, oh, a new IP address for the printer. Cool, I'll use that instead. So when we print something, you can see now it's getting requests. It's intercepting requests. The number is now 3. You see it's printing a job. Documents printed 1, the latest one here, and it's saving it on disk. But the clever thing is there's actually printing still. So I don't know. I have no clue that I just intercepted these calls here. And now I have a job something that bin, which is the actual print job that was just printed on the printer. So what happened now? So what happened was that it forced this printer to change the name. And then it took the same name. That has one sad side effect. If you check now, the printer, before it was called 2 here, but it changed its name to 3 because it was like, well, it can't be called the same, so just like incrementing the number. So if I take it over now, do the same thing again, and just cancel, and try again. You see now it's called 4. And so every time you do this, the printer is like, what the fuck? Why is somebody always taking my name? And it just keeps incrementing this number. So if you suddenly see that you have like printers on your network with like a number after them, then you know I've been at your network. Sorry. So, do you guys have any questions? There's one there. You're going to get a mic, so everybody can hear it.
So, have you actually used this in your office?
Yes.
Any special things you want to tell us about it?
Any special what, sorry?
Things that you've seen or something.
Yeah. No, well, I don't want to get fired.
Okay, nice.
So I did it while nobody was at work, and I just wanted to see if it would work, and tested it with one of my colleagues. He knew what was going on. I know that's a really, really boring answer to that question, but and then I went in and I renamed the printer afterwards to the original name. So because otherwise, when I'm shutting down this man in the middle program, now everybody can't print anymore because their configuration is still trying to use the old name, but the printer now changed its name. No, actually, I can't just unplug the printer and turn it on again because this is true. This is in the RFC standard. It says specifically that whenever you change your name because of this naming collision, you are forced, if you want to follow the standard, to keep the new name, even after a reboot. So, any other questions?
While you were adding the new printer, first it was appearing like an option that was downloading drivers,
yeah.
And then you selected the other option when it appeared. Like, does it always work, or the printer has to be added like in a special way that allows for your tool to work?
So what was going on there was that for some reason, I don't know if it was the setup with my phone or something like that, it was probably related to some packet loss. So my computer couldn't figure out that the printer was capable of IPP or something like that. So yeah, I think So it said, okay, this printer does not talk IPP, so I need to download some drivers to make it work. And then when I tried again, it figured out, it supports IPP, so it would do it.
Okay, so it just works with any IP printer?
Yeah, it
okay,
works
cool.
with any IPP printer that uses Bonjour or ZeroConf to advertise itself on the network. And my experience is that that most printers today who have like either Wi-Fi or network, most printers today support that standard. Because it's like every time you are at an office or at a school and click add a printer and it just appears, it's usually because it's using Bonjour to make it appear.
Okay, thank you.
So, any other questions?
I have some stickers and I have a T-shirt that. Does anybody here want a T-shirt? Whoa! I only have one T-shirt. I'm gonna give it to you because you asked a good question. There you go. And if you guys like coffee, I have some awesome coffee stickers that you can come up and get afterwards. Any other questions?
I think. Oh.
Nope. Yeah, you can't get another T-shirt.
I don't want the coffee, but
You only get one T-shirt.
that's okay. I also wanted to ask, like, what was the feedback you got online when you published this tool? Like, is this actually used in an attack, or?
I don't know if anybody used it. I published it because this is technically not a security flaw. This is not a flaw in the standard. That's an important point. So normally when you discover a security vulnerability, what you're obliged to do is You have to contact the people who can fix it before you disclose it. But this is not a security vulnerability. Well, it is technically a vulnerability, but it's not a bug. It's not like somebody wrote some bad software, made a buffer overflow or something. It's just like that's how the standard works. To be able to have this easy configuration, we have these drawbacks. So the way to fix it would be to use something like DNSSEC, as Paul was talking about earlier, if you were at the first talk today. So that's why I published it. And I don't know if, to get back to your question, if anybody used it. It has like 43 stars on GitHub, so somebody like it. But I don't know. I haven't heard anything. Yeah.
All right, any other questions? Oh, yeah.
Hi, what is the most challenging thing in your work?
In my...
In what you do, what is in your, well, my question is, what is the most challenging thing that you face when you are working?
Good question. Most challenging thing I face when I'm working. So like, yeah, dealing with undefined stuff. No, so at my job so my daily job when I'm not doing this crazy stuff, it's working at Opbeat, and I'm writing this Node agent, this piece of code that runs at all our users and all our customers' infrastructure. It sits on their server, on their production servers. It's running their websites and everything. And it sits there, and it monitors what's going on. And if I write something that's like broken, I can take down their servers. And if it's slow, their servers are slow. So, and it's easy to, if you own all the hardware, or if it's your own website, it's easy to handle because, hey, you control the entire environment. But if your code is going to run in the same way, no matter if people are running this version of Node, or they have this load balancer in front, or they are like running on this weird architecture, and then you get like a bug report saying, it doesn't work, or it's saying weird things. You're like, what the f? It's that is really, really challenging. It's really challenging that to write software that runs on somebody else's computer and that you can't debug easily. I don't know if that's a good answer, but when I do open source software, like that's not for the company. In the beginning, the challenging thing was to just be able to publish it and say, okay, hey, I made this software, like, do you guys want to use it? And then I got like 0 stars on GitHub. It's like, what the fuck? Nobody liked my stuff, or maybe I was afraid that people were going to read my source code and figure out that I don't know how to program or something. Say, hey, you're using this thing wrong, or. But that's totally wrong because first of all, nobody ever reads your source code anyway. So, and people are usually in the open source community extremely good at giving positive feedback. Normally. So I mean, I would encourage everybody to just like get involved in open source. I know that has nothing to do with your question, but does it make sense?
Yes, it does.
All right, any more questions? So,
I like how we just like plug open source software at the end. I just.
So let's give a big round of applause to Thomas.
Oh, and remember stickers. Thank you. If you want stickers, they're up here.
So everybody, I don't know if anyone signed for the workshops next. Just to give you a heads up, it's going to be like in those rooms. I think probably most of you already know. Yeah, the cake. We love cake. Cake! Who wants cake? Cake! Yeah. So thank you everyone. This was the great edition of SINFO. So hope you like it. What?